Unit 5D, Speed and Velocity. Recall, the formula for speed is distance traveled by the time the trip takes. Essentially, it is the rate of travel of an object as it moves from point A to point B along a path. The symbolic formula for speed is v equals d over t. It is a scalar quantity and includes only the magnitude, the number that represents the amount or size, and the units. Velocity is often confused with speed, but it has a few major differences. The formula for velocity is displacement over time interval. Since displacement is simply the change in position denoted with the symbol delta d, it can be described as the rate of displacement between points A to B in a straight line, or the rate of change in position. The formula can be written as vector v equals delta d over delta t. It's a vector quantity, so it has magnitude with units and includes direction as well. This example shows a journey from point A to point B. To calculate speed, we look at the distance of the journey along the path, which is the blue line. Let's assume the distance is 450 meters and the trip takes 25 seconds. Speed equals distance over time. V equals d over t. And subbing in d, distance, and time, we have speed equals 450 divided by 25 seconds. The speed for this trip is 18 meters per second. To calculate velocity for this trip, we need to know the displacement, not the distance. Displacement is the change in position, simply the distance between where you started and where you ended, which is the straight line in red. Let's assume the displacement is 100 meters to the right, which we expect to be less than the distance due to its shorter length. Time is still 25 seconds. Velocity is displacement over time interval. It can be written as delta d over delta t. Velocity is 100 meters to the right divided by 25 seconds, which equals 4 meters per second to the right, or simply plus 4 meters per second. We have a slight issue, as not all objects can travel at perfectly uniform motion, due to things like uneven path, headwinds, tailwinds, friction, changes in speed, etc. So what we do is we use average velocity. Average velocity acknowledges these variations and calculates velocities as though these variations cancel each other out. It's similar to averaging your test scores. Your low test scores are averaged out by your high test scores, and your median scores stay the same. The formula is the same as velocity, but includes the subscript AV, or average, to show that the variations have been normalized or averaged out. So let's take a look at our last example. It can be rewritten to show that the calculation takes into account variations in the object's motion. As you can see, the entire calculation is exactly the same, except that we use velocity average for velocity. So what would two objects with the same speed and velocity look like? Well, they would simply need to be traveling at the same speed in the same direction, like these two cars. This example also works. How about same speed, different velocity? Well, they would simply just have to travel at the same speed but different directions like this. Another example might be this. Different speed and velocity is much more apparent, as seen in these two vehicles.